To chapter 5.2, dividing monomials. We're again seeing the importance of knowing fluency, knowing your times tables, knowing your multiples, knowing your factors, and how we're going to simplify these fractions. We need to understand that all fractions must be simplified. Lowest simplification, common factors, etc., simplifying 28 over 35. We notice that we break it into prime factorizations, which is a great way, a very nice technique. And what we're looking at here is a common factor. So we see that 28 and 35 have a common factor of 7. We can reduce it by 7 over 7, which is equal to 1. So we're producing equivalent fractions. So we're not changing the value, we're just changing the facade, the look of it. Here, this is not prime factorization per se, but we are finding a common factor, reducing it. And I like this. This is really good also because we see that it can be that negative. There's only one negative. It can be in the numerator, it can be outside of the fraction, or it can also be, it can look like this. It can be in the denominator, but there's only one. Every single time there's only one. You can't have two because if you had two, they cancel and make a positive. And then we have our like bases. When we divide like bases, we subtract their exponents. I don't agree with this technique. They say, hey, when the numerator is greater than the denominator, we're going to do this. I think that this is illogical. It doesn't really, it doesn't make sense to me. I'd much rather deal with the negative exponent. In this case, if you have x to the third over x to the eighth, you're going to still use this technique. That becomes x to the 3 minus 8 or x to the negative 5. Now, if you want to get rid of that negative exponent, yes, you can convert it to that. Changing the sign of the exponent, you change the location of the base. This is in the numerator. When we change the sign, it goes into the denominator. So some of the things that we will be looking at. So if we want to do prime factorization, we would do it in this manner. Mental math, you should be able to do the prime factorization of some of these basic numbers mentally and see what you end up with. And 5, 6 would be your answer. I'm going to look to reduce, and we can do something relatively easy. We can find just a common factor. We don't always have to choose the greatest common factor. We can just find a common factor. And then we see, oh, maybe now I can see that 12 goes into that, and we get 2/3. So this is another common factor, and this is the GCF of this fraction. It's not the GCF of that. 24 would have been the GCF of that because you have 2 and 12 that you've reduced that fraction by. So lots of different techniques, lots of different ways to look at this. If you don't see, I see that 9 goes into both of those. So 9 goes into that. And now I can see that I can actually reduce it by 2. I still have some reduction to do, but everything must be in lowest, simplest form. Here we have a common base to an exponent. So I'm going to do it. Since we're dividing, we subtract their exponents. This takes place in the numerator, and this gives us 10 to the negative 3. Assume that no denominator equals 0. It doesn't say anything about having negative exponents, so we could write that as our answer, or you could write this as your answer, or if we need to simplify it completely, we would have this as our answer. So depending on what the criteria is, you're going to get a whole bunch of different answers. So 10 to the 8 minus 5, which is 10 to the third, which equals 1,000. That's a 1 with 3 zeros. Here, we would deal with the coefficients differently than we're going to deal with the variables. 10 over 2 reduces to 5. A over A equals 1. So we get 5. The A's would cancel. Again, variables will cancel. 12 over 4 is equal to 3. I'm going to cross cancel. These are not like bases. I'm dealing with these as constants. That gives me a 3. And then I'm going to deal with these bases and exponents differently. So this is 3 times 10 to the 3 minus 4, which is 3 times 10 to the negative 1, which is 3 times 1 over 10, which equals 3/10. So that's how I'm going to do that super fast. I'm not going to multiply those. I'm not going to multiply these and then deal with the division. I like them all factored out, broken out. So again, I'm going to deal with the constants differently than I'm going to deal with the like base. Yeah. That's going to give me 2/3. This is going to give me x to the second, and I can write it like that. I could also, that could be my answer. That's not a bad answer. I can write this also. That's an acceptable answer. 4 over 20 is going to be 1/5 n to the 6 minus 4. So we can have n to the second over 5 is a great answer. You can have 1/5 n to the second. That's an okay answer. You cannot have a 1. Do not write a 1 in here. That is unnecessary. We would not write that. But the only time we would see it is in this form. Okay? 2 over 16, and then we have x to the 5th minus 4. So I'm going to have x over 8 is going to be my answer. 12/3 is going to give me 4. X in the denominator doesn't have a pair, and then we have y to the 3 minus 2. So that's 4y over x. So we continue to see how fast we can reduce these. I'm going to deal with the coefficients, 4 and 16, which gives me 1/4. A to the second minus 1, b to the 1 minus 2. So that gives me a, b to the negative 1 over 4, which, depending, doesn't say anything about no negative exponents, so that would be okay. But I would much rather do this. We'd move the negative exponent down into the denominator. That's going to be the much easier, negative 2/3. I have x to the second minus 1, y to the 3 minus 2. So that gives me negative 2xy over 3. Two negatives are going to cancel, 8 and 20. 8 does not go into 20, so I can't reduce it. I can reduce it by 4, and that's 2/5. And we get a to the second minus 1, b to the 1 minus 1. And that's 2a, b to the 0. b to the 0 is equal to 1, so we get 2a over 5. And think about it, b to the 1 minus 1 is b to the 0, and b over b is going to cancel. Negative 32 over 24, 6? No, 8. 8 goes into both of those. Negative, negative, so those are going to cancel. So that's 4/3. B doesn't have a partner, C doesn't have a partner, and then we'll do with the D, 3 minus 2. So 4CD over 3B. I'm looking for partners there. Negative 21, negative 14, 7, so that's 3 over 2. B doesn't have a partner. C does, c to the 3 minus 1. D squared doesn't have a partner, so it'll stay down there. So we get 3bc squared over 2d squared. 30, negative 35, so that's 6 and negative 7. X doesn't have a partner, y doesn't have a partner, z to the 3 minus 2. So that leaves us with 6xz over negative 7y. And we wouldn't write z to the first, we just write z. X has a partner, so 2 minus 3. Y has partner, 1 minus 3. Z has a partner, 3 minus 3. So x to the negative 1, y to the negative 2, z to the 0. So z to the 0 equals 1. X to the negative 1 would go in the denominator. Y to the negative 2 would go into the denominator. And I would write that. That's the easiest way to write that simplification. A, 2 minus 2, B, 4 minus 1, C, 1 minus 3. That's A to the 0, B to the third, C to the negative 2. So A to the 0 is 1, B to the third stays in the numerator, C to the negative 2, the 2 goes into the denominator and becomes positive. 35/25, 7/5, A squared minus 1, B to the third minus 1, C to the 1 minus 1. 7a b squared c to the 0 over 5. C to the 0 can be simplified, so 7ab squared over 5. 26/52, that's doubled, so that's 1/2. I'm not going to write a 1. I'll just put the 2 in the denominator. X to the second minus 1, y to the 1 minus 1, z to the 1 minus 1. So x, y to the 0, z to the 0 over 2, which can be written as x over 2. No 1's in front of the x, no 1 as an exponent. That's the best writing. So as we see here, the only difference is we can't cancel what's inside these parentheses because we have an exponent. So we have to do GEMDAS. We have to do grouping symbols. We have to do that exponent. It's not actually grouping symbols because there's nothing we can multiply inside those grouping symbols. It's actually the exponent that we are simplifying. We're going to distribute that square into the 9 and the x, hence why it becomes 81x squared. We're going to distribute the 3, exponent of 3 to the 3, which makes 27, and then we'll deal with them. Then we'll deal with the coefficients and the like bases. So we have some simplifying to do. So that's 2 to the third, x to the third over 2x to the third. Watch this. We don't have to simplify this because we have like bases. So that's 2 to the 3 minus 1, x to the 3 minus 3, which is 2 squared x to the 0, which just gives us 4. That's a nice efficient way. We're going to utilize this. So this is 5m squared over 5 squared m squared. We're distributing the square to each of the terms. Now we again have like bases. This is 5 to the first, 5 to the second, like bases. So that's 5 to the 1 minus 2, m to the 2 minus 2. 5 to the 1 minus 2 becomes 5 to the negative 1, n to the 0. 5 to the negative 1 is 1 over 5. 5 goes in the denominator. Change the sign of the exponent. We change the location. So we're going to distribute 2 to the third. Ooh, no, okay. 2 to the third times t to the 2 times 3. When we have a power of a power, we multiply over 2 squared times t to the 3 times 2. So that's 2 to the third t to the sixth over 2 to the second t to the sixth. Like bases, 2 to the 3 minus 2, t to the 6 minus 6. 2 to the first, t to the 0, which just leaves us with 2. 4 to the third times a to the 2 times 3 over 4 squared times a to the 3 times 2. That's 4 to the third over a to the 6 over 4 to the second, a to the 6th, which simplifies to 4 to the third minus 2, a to the 6 minus 6, 4 to the first, a to the 0, and 4 to the first is 4. We notice that we're kind of doing the same things. We're going to distribute 3 squared a squared b squared over 3a squared b. We can again do this. 3 to the 2 minus 1, a to the 2 minus 2, b to the 2 minus 1. 3 to the first, a to the 0, b to the first can be written as 3b. 2 to the third, m to the third, n to the third, over 2m to the third, n to the second. That's 2 to the 3 minus 1, m to the 3 minus 3, n to the 3 minus 2. 2 squared, m to the 0, n to the first, and to the second is 4n. Now, this is good. This isn't interesting. So these have like bases. So instead of distributing it out, these have like bases. So we are going to subtract because we're dividing. So this becomes the quantity of negative z to the 6 minus 3, which is negative z to the third, which now becomes, this is an invisible negative 1. So we have the quantity of negative 1 to the third and z to the third. I distributed to both of the items, the coefficient of z and the variable z. Negative 1 to the third is negative 1, z to the third. And that's my answer. We again have like bases. That like base is negative a to the 5 minus 3 because we're dividing. And we get, again, we're going to get negative a to the second. This time we have negative 1 to the second, a to the second. Negative 1 to the second is positive 1. So my answer is a squared. You saw this type of problem on the last placement test, or on the last assessment, Chapter 7 assessment. A lot of students got these incorrect because they did not understand the quantity of that negative. These are not like bases this time, so we have to distribute this to 3 of the things. So we have negative 1 to the 7th, x to the 7th, y to the 7th, over x, y to the 7th. So negative 1 to the 7th doesn't have a partner. That's going to be negative 1 to the 7th. X has a common base, 7 minus 1. Y to the 7 minus 7. This exponent right here, this exponent only goes to this variable. There's an invisible 1 right here. So that's x to the first. Hence why we have 7 minus 1. So now let's simplify. Negative 1 to an odd power is still going to be negative. We have x to the 6th, y to the 0. So we get negative x to the 6th. No quantities, no parentheses. That coefficient was dealt with by itself. Not like bases, so we're going to distribute negative 1 to the 4th, and then t to the 3 times 4 over negative 1 to the 5th times t to the 2 times 5. So we now have like bases with the negative 1. Let's simplify. Negative 1 to the 4th times t to the 12th over negative 1 to the 5th times t to the 10th. We are going to now do the like bases. That's quantity of negative 1 to the 4 minus 5, t to the 12 minus 10. This equals negative 1 to the negative 1, t to the second. So we can do this. This is t to the second over negative 1 to the 1, which gives us t to the second over negative 1. Now I would not leave this as an answer. You have to simplify this to this. You must, cannot leave as answer. Much like there's no reason we would never leave this. We would never leave this as an answer. Must be simplified. must be simplified. Can't have a -1 under there. You would have to rewrite it like that. Must be simplified. Very important ideology here. All right, so now we're going to get, oh, missing factor. Okay, so we're going to break 8 into 2 times 2 times 2 and t times t times t times t. We can look at in that sort of saying, hey, what's that missing part? So let's find the 2t, and what would be left? Well, this is what's left. So that's technically 4t to the third. So this must be 4t to the third. Okay, that's one way of looking. We take out the factor and we look at it. Technically, another way to do this is you look at 2. 2 times what is 10? Well, that's going to be 5. W squared, oh, let's now do the other part. W squared times what equals W fourth? Well, that's going to be W squared. So this is going to be what my question mark is equal. That's a nice way of doing it. So we, again, will do that. So let's look at coefficients. So that's 3. Let's look at the a's. A squared, a cubed. We're missing an a. And let's look at b squared, b to the fifth. That's b to the third. So 3ab to the third. It's probably the easiest way to do this. So now we can do it real fast. 5 into 15 is 3. P into p doesn't need anything. Q to the third is q squared. Nice, efficient. 7 into -28 is -4. X squared doesn't need any more. Y to the third. -8. 32 is just going to be +4. A to the fourth, b to the fourth. You see how simple this is? Okay, well, hopefully you see what simple is. 21x to the third, 14x squared. I would tell you to break this down into its prime factorizations. Is a nice way of learning this. And now GCF, the C, circle the common. Circle what they have in common. They have an x in common. They have a second x in common. They have a 7 in common. So the GCF is going to be 7 times x, or 7x squared. Really, really easy. I mean, this is the most basic way. And once you get really good at it, you can see how we're finding common factors in how we're looking to see what do they have in common. Well, of course, they're going to have 2 because they have the least is the most, as I always said. Or least you take the greatest, greatest you take the least. So you take what they have in common. So greatest, you take the least that they have. A to the third, a to the second. What's the least? A to the second. B to the second, b to the third. What's the least? B to the second. So that's another little trick. That one's, so 6 and 8 is going to be 2x y to the second. That's what our GCF is going to be. And you should start getting good at it. 18c squared d to the third. Now you can break it up. 2 times 3 times 3, prime factorization of 18. C times c, d times d times d. But as I said, you shouldn't be doing this in high school. You should be able to see what common factors are. Greatest common factors. So if we look at the coefficients, 2 and 3, if we look at the variables, c and c, and then we look at the other variable. So my GCF is going to be 2 times 3 times c times c times d, 6c squared d. Now, are you able to see that from looking at it here, that that's the greatest common factor that goes in, divisible. So it's going to be 5 p q r is going to be my GCF. That's how good you should be. That's how fast you should be able to do that type of factoring, finding greatest common factors. That's your goal. That's what you're shooting for, to be proficient and fluent in high school in order to test out of Algebra 1.